Okay, let's continue with our simple interest problems examples. So number 4 says, how many days will it take for a sum of $1,500 to earn $25 in interest if it is deposited in a bank paying 5% per year, use a 365-day year? Okay, so we're basically solving this equation for every one of the variables that we could possibly imagine, because you could get asked to do that in your homework and on a quiz or on a test. So let's see, we are looking for how many days? So we are looking for the T. We don't know the T. We do know what was invested, so we know that this is the principal. We know the interest that it's gaining, and we know that the rate is 0.05 or 5%. So it looks like probably the best way to do this is to do the I equals PRT version. There's no reason to use an accumulated amount equation because we don't have an A and we're not looking for an A. So we have 25 equaling 1,500 times 0.05 times T. So it looks like we want to say, what is 1,500 times 0.05? 75. So 25 equals 75T. Divide by the 75. And 25 over 75 reduces to 1/3. So we get T equals 1/3. Now, that is not in the correct format, though. It says how many days. So the answer is not 1/3 days, right? Because the T is always how many years. So right now we have that it's 1/3 of a year. If I need to translate that to days, then I need to take 1/3 times 365. So looks like 1/3 times 365 would give us about 122 days. That's what I'm going to round that to. Because 121 days wouldn't quite do it, but 122 days would. Okay, so the last of our simple interest problems says, determine the simple interest rate. So this time we're looking for the R, at which $1,200 will grow to $1,250 in 8 months. So it looks like we have our principal, our accumulated amount, and we have a time 8 out of 12. Now I'm going to reduce this one correctly. 8 out of 12 reduces to 2/3 of a year. Okay, so I'm going to use the A equals P1 plus RT formula. The accumulated amount is 1,250. Principal is 1,200. 1 plus, I don't know the rate, but the time is 2/3. Okay, so to solve this, it looks like I need to I have to kind of go from the outside in. First, I need to divide by 1,200 on both sides to get rid of that. So 1,250 divided by 1,200 does not come out nice, so I'm going to try a second math fraction on it. That's 25 over 24, so that'll be better. The next thing I need to do is subtract 1. So 25 over 24, I'm just going to keep a running total for right now. Minus 1 gives me 1 over 24. And now I would need to divide by, either divide by 2/3 or multiply by 3/2, however you want to do that. So I'm going to just say, okay, I want to divide this by 2/3. And we got 0.0625 as an actual percentage, which is most likely how they're going to want that. I'm going to adjust, so I'm going to move this decimal point over 2 places, and I'm going to say this is 6.25%. So we solved all of the simple interest problems in every way imaginable. We solved for A, we solved for I, we solved for P, we solved for R, and we solved for T. So you should be able to do any of those that they throw at you. Moving along from simple interest into the idea of compound interest. So this is more applicable really in the real world if you're investing money in a bank or something like that. Because with compound interest, you're going to earn your interest and it's going to be periodically added to the principal. And then your interest is going to earn interest and be added in, and then that interest will earn interest and be added in. So this is the more common way we do this. Compounding is the word for when they actually add the interest onto your account. So here's an example. It says if you deposit $10,000 in an account at 6.5% annual interest, your balance after 1 year is, you can just do a simple interest formula for that single year. You would take your 10,000, you would add whatever 6.5% of that 10,000 is, which is 650, and at the end of year 1 you would have 10,650. That interest becomes part of your new balance. So then for the second year, you now have a new P. So your P here is now a new principal. Now you're going to earn 6.5% of this new bigger principal. So your I grows as it goes. And then you add that in to get your year 2 total. Now your P3, your third principal, would be $11,342.25. That's what you would start with the next year. And then your interest for that year would be even more. So the amount of interest you're earning grows along with your principal. Compounding usually occurs after the end of a year, quarter, month, or day. And the interval of time between these interest calculations is called the conversion period. So what you will need to know, the formula that I'm giving you in the notes is my personal favorite way to remember these formulas. It won't necessarily be the one that you see in Newton or in other websites if you go to other websites. It means the same thing, but everyone uses different variables to mean different things. This will be the formula that I give you on a formula sheet that you can use on your test though. So I encourage you to look at it this way because honestly, I feel like some of the ways that they write them are a little bit confusing. So for me, A is going to be like the accumulated amount, the current amount. P is the principal. R is your annual interest rate in decimal form. M is the number of times the interest is compounded per year, and T is the time in years. So usually our M's then, if you compound once a year, your M will be 1. If you compound it quarterly, M will be 4. If you compound it monthly, M will be 12. And if you compound it daily, M will be 365. And the one that I forgot to add in here is, I don't know if you'll get this very often, but if you compound it weekly, then how many times a year is that? There are 52 weeks in a year. So your M could be 52 if you ever actually get one of those. Okay, so let's find, using this formula, the accumulated amount, A, if we invest $1,000 for 6 years at a huge interest rate, 8.5% interest compounded these different times. So these are all going to be set up similarly. The only thing that's going to change is that M value. So for semi-annually, we'll have A equals, the principal is 1,000, then a big parenthesis, 1 plus the rate. So 8.5% is 0.085. Compounding it semi-annually is 2 times a year. And then my exponent is 2 times 6. 2 times 6 for 6 years. I'm going to actually set all these up and then go to calculating, because when we calculate them, we can sort of just change one value. So if they're quarterly compounding, everything stays the same except for that M value. So 1,000 plus quantity 1 plus 0.085 over quarterly would be 4 times a year, and my exponent would be 4 times 6 If we were doing this monthly, we would have 1,000 times the quantity 1 plus 0.085 over 12 to the 12 times 6. And daily, 1,000 plus the quantity 1 plus 0.085 over 365 to the 365 times 6 power. Okay, I recommend when you're doing these, you don't have to. You can type it all in if you want to, or when they become a little bit more complicated, it might be nice for you to actually figure out what that exponent is so that you don't have to type the exponent in parentheses, but you can actually go straight for it just like this if you wish. As long as you type in the correct parentheses, you'll be fine. So I can type in, for the first one, 1,000 parentheses 1 plus 0.085 over 2 to the, and you do need parentheses, to the 2 times 6, unless you're just going to type 12 there. If you just want to type 12, you can just type 12 with no parentheses. Okay, so on this one, it looks like the balance after the 6 years is $1,647.83. I'm going to round off to the nearest cent on these. Okay, so I'm going to just do a second enter and bring that up, and I'm going to go in and edit only the 2, changing it to a 4. As long as you don't change how many numbers you put in there, you can actually just do that. So second enter is how to bring that back up if you want to. So this one is $1,656.42. Now, if I do my second enter again, the problem now is that 12 is going to be more. So it's going to require me to either go in and do an insert, like I can put a 1 and then I have to actually insert the next one. I have to do a second insert and do a 2. So you can do this if you're careful, or you might just want to type it all back in. But at any rate, you should get $1,662.30. And for this last one, instead of doing all the inserting, I'm just going to retype it because I've got to change 1 plus 0.085 divided by 365. Oops. Close that up to the parentheses 365 times 6 power. And this one comes out as $1,665.19. So if we take a look at all of those, it says which one has the highest value and why do you think that's so? So what you should notice here is that they're increasing. Each one of these is larger than the next. So this one has the highest balance. And why would that be so? Why would it be that the more often you compound it, the more you actually make? So my answer for this is that you're earning interest on interest the most often. So you're earning interest on money that wasn't even yours to begin with the most often. That's the best bet. If all things are the same, considering if you're looking for an investment, if everything's the same across the board except for the compounding, choose the one that gets compounded the most often.